Hello, welcome friends. In the last video, we have derived the Lami's equation. Now let us try to solve the problems on the Lami's theorem. In this Lami's theorem, we have different problems. One is first category of problems are on cables. Cables are nothing. It is also called as rope. Sometimes it is also called as wire or a string. All the four titles, which cables, rope, wire, string, all will experience only tensile forces. So whenever a problem on these topics we come across, we're supposed to calculate tension in those segments. The second category of problems are on rollers. Rollers can be also called as cylinders or spheres. So we have two different category of problems to be solved by making use of this Lami's theorem. Friends, let me tell you the limitation of Lami's theorem. This Lami's theorem can be applied only when there are three forces in which one is known and two are unknown. Then okay, if you have four number of forces acting at a particular point, then we cannot apply the Lami's theorem. In that case, we need to resolve all the forces along x and y and make use of equilibrium condition, that is summation of x is equal to 0 and summation of v is equal to 0. Okay, that by making use of those two equilibrium condition we can find the number of unknowns. So first let us deal with the problems on string, cables, rope and wires. So all the three titles stands for the same thing. So these are the this all four are experience only tensile force. So as the figure given is, for the first I will read the statement given for a problem. First problem is two cables are connected at A and B as shown in figure. A force of 30 kN is applied at C. Determine the forces in the cable C and CB. So as I told, the cable, string, rope, wire are a tensile members. So here we are supposed to calculate tension created when you apply 30 kN in a segment C and CB. To apply Lami's theorem, let us first draw the free body diagram. Free body diagram. As a free body diagram, very easy. So what we do is first draw a plus mark, and this point is nothing but point C. Okay, now here the force applied, always the force will be acting vertically down and it's 30 kilonewton. It will be always acting vertically down. Now here we have two segments, that is CB and CA. So CB will be in first quadrant and CA will be in second quadrant. And now this shaded portion is nothing but fixed support or fixed support. I will remove this fixed support. So as we know that the forces in these segments will be tension, and the direction of tension will be always moving away from the joint considered. The direction of the tensile force will be always moving from the joint considered. Here I have considered joint C, so direction of the forces should be moving away from C. So first here we need to calculate tension in is the portion CB. So suffix CB. T stands for tension in portion CB. Similarly, here again arrow mark should be moving away from the C, and here the segment is CA. So T stands tension in portion CA. Now look at here, angle given for this portion CB is 45 with respect to x-axis. So this angle is 45, right, as it is. And then for CA the angle is 30 degree. Okay, this is what given. But to apply the Lami's theorem, we should know all the angles in this quadrant. So in the first quadrant, if this angle is 45, the remaining angle is 45 because one quadrant is of 90 degree. So in the second quadrant, the angle given for TCA is 30, so remaining is 60. So look at here, the angle given should be with the arc and the angle which we have calculated should be without arc. So it will be easy to understand which angle is given and which is not. Okay, so here there is nothing like, so one quadrant is of 90, so it is 90 and this will be 90. Okay, fine. Now let us try to apply the Lami's theorem. Apply Lami's theorem. First, always write known force. Which is a known force here? 30 is a known force and 2 are unknown. So I can easily apply the Lami's theorem. So first I will write 30 divided by sine of angle between the opposite two forces. When I consider the force 30, the opposite two forces are TCA and TCB. The angle between these two, angle we need to consider between these two forces. What is the angle between these two? 60 plus 45. So right here 60 plus 45 is equal to, now we'll consider the force TCB. I consider this for TCB divided by sine of angle between the opposite two forces. When I consider TCB, the opposite two forces become TCA and this 30. These are the two opposite forces. The angle between these two is 90 plus 30. So 30 plus 90 or 90 plus 30, both one and the same, is equal to, now I will consider TCA divided by sine of, when I consider TCA, the opposite two forces are TCB and 30. What is the angle between these two? 90 plus 45 or 45 plus 90, both one are the same. So this becomes 30 divided by sine of 60 plus 105 is equal to TCB divided by sine of 120 is equal to TCA divided by sine of 135. Now the question asked is to calculate tension in CB and CA. So first consider first two. 30 divided by sine 105 is equal to TCB divided by sine of 120. We want TCB, so just cross multiply with this 30 into sine 120 divided by sine 105. I will work out making use of calci. 30 multiplied by sine of 120 divided by sine of 105. It is 26.89 and it is in Newton, sorry, kilonewton. As the force given is kilonewton, so answer, whatever answer we get, that should be in kilonewton. Okay, similarly if I want TCA, again consider first and last. 30 divided by sine of 105 is equal to TCA divided by sine of 135. Now we want TCA is equal to 30, just cross multiply into sine 135 divided by sine of 105. Again I will make use of calci. 30 multiplied by sine of 135 divided by sine of 105. It is 21.96 kilonewton. That's it. So it is very easy.